Hello everyone, welcome back to another video on my YouTube channel. Today we'll be discussing another problem from the Blind 75 list of problems, and this problem is called threesome. In this problem we are given an array, nums, and we must find all triplets in this array. Triplets is 3 numbers in this array that sum up to 0. So for example, in this first example we are given the input array -1, 0, 1, 2, -1, -4. So in this, to get the sum 0, we'll have to find three numbers, that is triplets. So -1, 0, 1 is the first triplet that we get, which sums up to 0. And the second triplet that we can find is -1, 2, -1. So this is our result array, which has two triplets inside it. And notice that the order of the output and the order of the triplets does not matter. So we can even exchange these and exchange the numbers inside these. It will still be accepted. Now let's see how we'll solve this problem. Now consider that to get a triplet A, B, C, let me name it A, B, and C, such that A plus B plus C is 0, we'll need to find positive as well as negative numbers. So for example, in this example, we have 1 positive and 2 negative. In this we have 1 negative and 1 positive. Or we can have all three as zeros, which is very rare, but this can also be the answer. So we know that we need to get positive and negative numbers separated to find the answer. And for that, the best case is sorting this array. So let's first sort this array and see what we get. So quickly, let me just sort it in a separate line. So it will be -4, -1, -1, 0, 1, 2. And let me just, we are supposed to find three numbers. So let me just fix one number from these. So let's suppose I am fixing I at -4. And I have to find j and k in this remaining array. So what should be the value of j and k? We know I plus j plus k should be 0. So j plus k should be -i. So let's quickly hand simulate it. So -i in this case will be 4. So let's consider two pointers here. Let me just take j here and k here. Now what is j plus k? 2 minus 1 is 1. We find j plus k. And what was j plus k supposed to be? -i, which was 4. So we need to increase j and k now. So that means we'll do j plus plus. We'll move the left pointer towards the right to increase the value of j plus k. So when it moves here, it is still 1. We again move it to this pointer, it is again 0. And when moving it to the more rightwards towards this end, it becomes, j plus k becomes 2 plus 1, which is 3. It never becomes 4. So that means -4 can never be in our answer. Now, after this, we'll just increase the value of I. So let me just remove this. Now we move I here. And now I similarly find j and k here such that j plus k is equal to -i, which is 1. So let me put j here, k here. 2 minus 1 is 1. So in the first iteration only we got the answer. So now this condition became true, j plus k equals to -i. So we push this array into a result. So let me just build result here. So -1, -1, 2 is our first result. What then if both of these are equal? Or if this condition became true, then we do j plus plus and k minus minus simultaneously. So j comes here, k comes here. And this gets removed. Now what is j plus k? 1. It is again -i. So we push the second answer as well, which is -1, 0, and 1. And similarly, we'll keep on moving I, then calculate some 1 here, and then move I here, then try to calculate sum 1 here, sum 0 here. But we stop when we encounter zeros because now we can't find a value which sums to 0 in the remaining array. So let's see how we'll code this, and you will be able to better understand this with code. So let's start. And before starting, what would be the time complexity here? This I loop is moving n times, and this 2-pointer approach is also n. So it will be n into n, which will be O of n square. And what would be the space complexity? Initially, we are sorting the array. Remember that. So that would be O of n log n. So this will be, time will be O of n square plus n log n, which will end to be O of n square only. So let me just write that here real quick. N log n plus, and space complexity will be O of 1 if we exclude the space taken by sorting. So in sorting, the space taken by sorting depends on the algorithm that we are using. So I'm not considering that. Other than that, we are not using any extra space. So let's say it is O of 1. Now let's look at the implementation for this problem. We are given an input array nums and also a function called 3sum. Let's start by sorting this input array. So sort nums. Once the array is sorted, I want to create a result vector that will have all the triplets, and at the end I'll just return this. Now what I want to do for this result is iterate over this array and picks the first number in the triplet, which will be I. And what I'll do here is call another function to sum on the remaining array. So let me just pass that real quick. So I'll pass the current number, which will be, let's just call it nums of I, and also the result vector, so I can push the results. Now let's create this function. So it will be void to sum, and this has the original input array nums, and let me call it A, the first number in the triplet which we selected, and then I'll also pass the result array, the vector that we created by reference. Now the following code in this function will be the simple 2-pointer approach that we discussed. So let me just have L, which will be, okay, I'll also need the I. Let's just pass I here. So I, and let me call it I. So L will be I plus 1, and R will be nums dot size minus 1, and while condition, and the sum currently will be nums of I plus nums of L plus nums of R. So this is the current sum that I have. Now if this sum is less than 0, what I want to do to increase the sum is, I want to bring it to 0 essentially. For that I can either move L or decrease R. So I'll increase L. Because the array is sorted, I want to increase this sum. If sum is greater than 0, in that case I want to reduce R because I want to decrease the sum. And if sum is equal to 0, what I do is I push the result into the arrays vector. So let's create that. It will be nums of I, nums of L, and nums of R. Now once I have the result pushed, what do I do? I'll also do L plus plus and R minus minus to move on to the next iteration. Okay, let's try running this. Okay, there is one wrong test case with wrong answer in which we are getting -101 twice. So we want to avoid duplicates as well. Now to avoid duplicates, what we can do is to avoid duplicates in this, so we have -1 twice. That is why we are getting -101 twice, because -1 is I, then again I becomes -1. So to avoid that, what we can do is, here I can put a condition that if nums I minus 1 is not equal to nums I, and this condition I only have to run when I is not equal to 0. So I can just put if I equals 0 as a condition here, and just add that here. Okay, so this works, all 3 input test cases. One other optimization that we talked about is stopping when this I reaches a positive number that is greater than 0. So that condition also I can add here, so that we don't waste time after we reach a positive number at I. So that would be and nums of I is less than equal to 0. Okay, now let's try running it once more and then submitting it. Let's submit. Okay, for this input test case we are still getting one more duplicate, -20022. So -2 0 2, we move L and R, we again get 0 and 2. Okay, to avoid these duplicates we have to handle it somewhere here, because I duplicates are being handled here, so L and R duplicates we need to handle here. So for this, what we will do is, when we are pushing back the answer, we can either increase L or decrease R until we get a different number. So to do that, let me just see how I can do that. So while L is less than R and nums L is equal to nums of L minus 1, we keep doing L plus plus. Okay, this looks correct to me. Let's just try it out. So for -2, this is L, this is R. We push the result -2 0 2. We increment L, it decrease R. Now as this is same as the previous number, we do L plus plus again, and this L less than R condition becomes false and we come out. Okay, let's try this once more. Okay, all input test cases worked. Now let's try submitting it. See, our O and 2-pointer solution worked now, and you can also see how I improved on my solution looking at the test cases and hand simulating that. I hope that was helpful. Thanks for watching this video. Do like, share and subscribe to the channel. Happy coding!